go to neurotechx.com, you should be able to find, I believe that's the official path to an invite. Is that correct, John?
I believe it can be found from there. There's like it's a Heroku app.
Okay, then I can give that. Yeah, then
you can find it if you just Google like NeurotechX.
NeurotechX.heroku.app.
Use your kind of 21st century skills. You'll end up at a Heroku app site that you can then join through that. It's not too hard.
Sure. Slack for the actual. Sorry, Suhas. So you're in Slack already. Okay. Yeah. So if so, then follow Andre's instructions.
Okay, I'll look at this channel. Okay, thank you.
Yeah. Okay. I fear the future. Terrific. And so yeah, wanted to just cover these meetups have kind of opened up for all the cities. So we've definitely got we've got a lot of good material to cover today. But please, message us. If you could get on Slack, please do. You can keep up the conversation there, and also get in touch and tell us what if there are things that you'd like to present that you think would be of interest to the community. So I wanted to talk about. Well, I wanted to just say, if anybody hasn't seen it, that there is a NeurotechX challenge that was just posted on Wednesday, which is an epilepsy challenge with. Let me get the actual company. Does anybody have those details? Andre, you were looking at the particular. So this is using the Temple University Hospital clinical EEG dataset, and I will pull this up and share it in just 1 second.
Yeah, it's
There we go.
Morgan, it's the Institute for Signal and Information Processing.
Yeah. So this is the if I can make that bigger, but so here's what was announced on Wednesday, and so I guess submissions are May 1st with a $5,000 first prize. I'm embarrassed to say I don't know novella, but this is an awesome opportunity for everyone to get familiar with this particular data set, as it really is the largest currently available public data set. And so I believe the complete corpus is like 15,000 recordings. It sounds like they're using a small subset, and it's everything that Temple had, right? So epilepsy is going to be one of those clinically requested EEG recordings. That doesn't mean all of them are. So 57 gigabytes. But what we could also point out here in terms of archive, I'm gonna go sanity. for those who aren't familiar with this particular paper, it's a great overview of both Antonio Ball has got experience with this, and then Frank Hutter, machine learning, auto ML person, that have previously worked with this data set. So it's definitely what I'm really hoping is that we can all get a little bit of experience of like what the pre-processing issues are and other things that that you might want to do, or that we can make easier for even when this challenge is no longer running. So for those who are interested, and then the other big announcement, let's see if I go, which I think I've got it here in terms of so was the new sorry, I'm not seeing it. Did I post the Ed Chang's lab posted new results showing speech, intracranial recordings to text from subjects that are reading. And
yeah, that was crazy.
That was awesome. Didn't I?
Yeah,
I thought I
amazing.
posted that, didn't I? Anyway, I can find. I think it's. I mean, will we forget it? Just Chang. And say EEG. What does he have? Speech.
Speech, intracranial electrodes, classificate. Could be it.
Let's see. Yeah, it's because this is
I think I got it in the chat here.
I'm afraid I don't have. I bet I don't have access. Well, maybe John will have access to that, but amazing results, and enough that apparently it got the marketing department at Facebook Reality Labs to post something too. Sorry. Did they? No, that's this is incredible accuracy that they're showing with these very like non-specific grids, right? That are just they're covering a very large area of cortex, but they're still able to record. I mean, pull out these sentences near almost perfectly.
Yeah, and there's some interesting figures in the paper where they're showing like the grids are in slightly different places on different patients, right? But also they have like something like the feature vector weights or something. So it's like the contribution of the different parts of the grid, the different brain regions to the decoding, and they're pretty heterogeneous.
Right.
Which is also interesting. It's not like you're always using the same bit of brain from every patient to achieve the performance.
Well, I mean, so the transfer is important just even across sentences, or I mean, it's handling that variability across sentences.
Not sure.
Okay, sorry. I'd love a copy.
Be arranged.
It's posted on the Zoom Slack. Sorry, Zoom chat. Does anyone know if it's real time or how fast is it? It's probably not real time.
Say again?
Oh, does anyone know how fast the decoding is?
Oh, I don't. But from what they showed, what was it, like December? It seemed like it was pretty fast. I mean, you know, they seem to have something that's trained that's doing the decoding. But I haven't actually read the paper.
Very
So-
cool. Yeah, I'll check it out. There was another paper that was similar, and they were saying like, oh, we could decode speech before it actually happens. I don't know if it was from the same group, but in my mind, the two papers were like, well, I'd rather look at this other paper than this paper. But yeah, I should look at both papers. Yeah.
Yeah. I mean, they definitely need, you know, they need something to be happening. I don't think anybody's performing magic yet. But you know, they've been working on this a long time, and we know that this is going to be great work. Super excited to see that. And then I just would say we had a great meeting with NeurotechX Paris. And so next Monday evening, which would be like our 11 o'clock, well, it's 11 o'clock Pacific time, 2 o'clock East Coast, is will be NeurotechX Paris Hack Night. And we're going to have Andrei Parfanov, who's the BrainFlow developer. Hopefully Pierre Clisson will be able to join, who developed TimeFlux, and Sylvain Chevalier, who did the latest code sprint with M&E Moab, as well as, you know, potentially. Sorry, it was David. Sorry, Mark. So Mark, I don't know if you know Conscious Labs, but they also develop some dry sensors that are compatible with Open BCI.
Oh yeah, I think we've seen them.
Yeah, so hopefully they'll talk a little bit, and I don't know if we'll be able to get. I don't believe NextMind is talking publicly yet about its little BCI setup, but anyway, for anybody whose time zone and or work availability allows them to catch Paris Hack Night, some of us will certainly try and join, and there's, you know, a lot of good developers working in you know, both in Paris and its environs, and Romain hosts that, so you can catch the details in the Paris Slack channel. Okay. So because I'm starting or just ending with the Paris things, Jaden, would you be ready to jump in?
Yeah, sure. Can you guys hear me?
Yeah. Hi.
Cool. How's it going?
Great to meet you. So Jaden's a student in Las Vegas, and
Yeah.
I'm gonna let you introduce yourself. Tell us a little bit about what you're doing for your PhD and your experience, because you had some engineering experience before too.
Yeah, so I'm working on my PhD in electrical and computer engineering. I just finished up my master's last spring. And so what I've been doing, what I started for my master's on the proposal and I'm working on now, albeit kind of slowly, is a program called the Nonverbal Communication Toolkit. And so I'm working with our UNLV's medical school to basically develop some type of system that reads, you know, physiological signals, EEG, GSR, eye tracking, or otherwise, and trying to figure out a way to like develop that and translate that into a language or some type of communication method for them. Because clearly there's a lot more going on underneath the hood for a lot of these people who are suffering from nonverbal disorders that they just have no way of communicating. And so we have a few partnerships with organizations like Opportunity Village and a music therapy organization that works specifically with nonverbal people. And once this is all over, we're going to be able to start doing our observations with them to actually collect data and work on the more human-centered design portions of it. So right now, I've just been kind of working on the EEG processing and just I'm working with the Open BCI headset and trying to just make sure I can process everything and at least recognize the signals. So once we start working with clients and persons, that we can actually like get stuff working right away instead of having to go through all the growing pains of testing the algorithms. And so that's why I actually worked on developing, I just shared with Morgan the version of the EEG notebooks that are centered to work on the BrainFlow API with the Open BCI headset. I still have to run a few tests to make sure everything works, but I've run all of the code on my like own code base separately, but it was very messy and not well documented at all. So I spent some time cleaning it up and sharing it. And so the nonverbal is what I do for my PhD thesis, but then I also work on another project with, let me see if I can share the link in the chat, with our robotics lab here on campus. And so we're participating in the ANA Avatar X Prize, which is to develop a robotic avatar for someone so that they could place it somewhere across the other end of the world and have them interact with the environment and experience it completely immersively. So we have a humanoid robot, the DRC Hubo, and we're using that mixed with a virtual reality interface. And so they brought me on board to help develop a BCI interface as well within the VR. And so I'm starting to work on that with them as well. And we're going to look at it using a combination of SSVP. And then I also have the Mind Effect decoder coming in, which I'm going to work on trying to build that into the interface as well, since they've had promising results with the HTC Vive.
Okay, but the Mind Effect is a low channel add-on to VR.
It's to the Open BCI.
Oh, it's to Open BCI.
Yeah.
Okay.
It's they have some of their representatives are in the Slack channel.
Sure. I mean, I saw some people posting, because they posted an API maybe like a couple months ago.
Yeah, so they're a Kickstarter, and they run this. Basically, what they sell in addition to their own like headband. But if you don't want that, you can slap it on your current Open BCI thing. And
say again, Ben? Go ahead. Go ahead.
No, so they also sell for like $100 and something. It's a Raspberry Pi with their algorithms loaded on it, and then also like a signal decoder that plugs in between the electrodes and the sight and daisy board. There you go.
This is them, right?
Yeah.
And I'm just curious. So just because people, is this, if they got one of these kind of, okay, so it's a strap. I see.
Yeah, it goes along the back of the 4 electrodes along the back of the head, the occipital lobe. And so they use, I've read a couple of the papers, they use broadband visually evoked potentials, which are similar to SSVPs, but they use, instead of specified frequencies, they use what are called gold codes, which are modulations of like essentially Morse code 1 zeros. And they have all these like calibration algorithms that basically allow you to fit a lot of different single buttons into one interface, because if you only use frequencies, they're going to have too much overlap depending on your refresh rate. And
so, sorry, I was trying to see if I could find the that particular, yeah. So it's like, it's there at about a minute.
Yeah.
Okay. And so they're doing the different buttons at different frequencies? Or?
So instead of having to have like a couple frequencies spanning all the letters until it lines up with what you're looking at, they use different modulations of short and long codes, which are called gold codes. So it's like 10110110111, and they modulate them so that each different button has its own frequency, so to speak, and can run its own classifier all at once. Then they also have another algorithm that basically, when you calibrate it, it determines which codes are nearest to each other that are too similar, and then we'll eventually like break them up so that it has the highest like contrast and classifications.
Interesting. Okay.
So it's kind of time domain like words in the like information theory sense, like snippets of information rather than frequency domain. So you're having like more you can kind of cram in.
Right.
And you don't have to wait so long to get a good frequency resolution.
Yeah, it's what they call it, like a convolution and deconvolution algorithm for it, which is how they figure out the specific arrangement of codes that they need to generate.
Huh. Does anybody know if somebody's looked at the kind of efficiency of that? I mean,
we were trying something like that in the Man Lab in Toronto this summer. We were trying to instead of having instead of having steady state at a single frequency, we were sweeping through frequencies and then call it chirplet.
Sure.
And then but it wasn't giving us much more an easier path forward. We didn't go down that path too long.
Okay.
That's a good idea. I saw another company that was doing good decoding. Maybe that they were doing something like that too.
Yeah.
Yeah, they show it takes about like I think 2 seconds from looking at a letter to classify it, about give or take. But I read the paper and thought, okay, I'll see if I can re-implement this algorithm, and it was a pretty hefty algorithm to re-implement, and I found it back in mid-February and saw that the Kickstarter was ending. I was like, I'll just buy it and get it that way and use it.
Sure. Well, so do you and you don't have to, but do you have any hardware demo that you can show us, or
not at the moment, I would say.
Okay, but you have a open BCI.
Yeah, I have it right on my bookshelf up there, as well as a Muse.
And a Muse, right?
Yeah.
Okay. So yeah, and did you post your GitHub?
I can post the link. I sent it to you earlier today, I believe. But
yeah,
I can
sure. Kyle's has a fork, Mac OS specific fork plus deep learning add-ons, and John's kind of maintaining. Is that safe to say, John? You're maintaining.
I think John merged my fork the other week.
Yeah,
I think so.
Maintaining is kind of
Okay.
I'll take it as a compliment. That's right, Kyle. I merged your stuff.
Did you say that there was a better chat to use in the Slack versus the one in the Zoom?
What would you say, John? Like, if somebody wanted to have a conversation about EEG notebooks on Slack.
EEG data channel.
Okay.
Oh, no, I'm just saying is if there's a preferred place for me to post the link to the GitHub over the Zoom chat or in the Slack.
Again, that EEG data channel on NeurotechX Slack is a good kind of general one. Or
sure.
Just general.
I mean, if you don't mind both, certainly while we're talking, then people don't have to switch out of the app if they can.
Yeah, I got it.
But that's great. I mean, so yeah, I mean, we were all excited just in the sense of like, it'd be great for the notebooks to have more hardware support.
Oh yeah.
And yeah, and this links in with what we were talking to Paris about, just because their time flux framework which is really designed to be a real-time analysis framework, but doesn't necessarily, is visualization independent. Also, has a kind of plug-in modular architecture, and I know others have been using BrainFlow inside TimeFlux to give BrainFlow. Yeah. So yeah. So I don't know if you're going to be available. I mean, it'd be awesome to have a demo with some open BCI hardware or their because Andre supports another package too, right? I mean, another piece of hardware.
Yeah, I saw BrainBit, I think he said.
BrainBit. Yeah. So so if anybody has BrainBit,
that was the band, right?
Yeah, I think it's another band. Yeah.
Oh, pretty neat actually, with the kind of big forky dry electrodes as well.
Yeah.
Big fat pins.
And so Andre couldn't make it today, but he is anxious to increase the hardware support in BrainFlow. And so he's curious if anybody's got access to hardware that's connected to the internet that would be willing to give him access so that he could work on hardware while he's locked down and he can't seem to order anything. And in particular, he's keen to add support for GTEC's unicorn amps. So if anybody's interested in getting Andre Parfenoff access to additional hardware for BrainFlow support, I'm sorry, BrainFlow, he would be most grateful. And if that's hardware that's not currently supported by an open source package, then you could get that driver support for free. I'm still hoping we can get, so Kyle, you don't have an EGI amp, do you? I don't know if Kyle's there. I mean,
Kyle, you're muted, Kyle.
Oh.
No, I don't have one in my house. Our campus is locked down now.
Okay, but you have one in the lab?
Yes, there are the other people that we share our group space with. Two of them have EGI.
Okay. And Gerton had the EGI too, right?
There was EGI there, but no, like Gerton's been using Brain Vision for a while. They have, and then they have huge grass amps. My 2009 paper's on like a giant cabinet grass amplifier.
Well, I did the same thing, but it was EEG of invertebrates.
Cool.
Nice. Okay. So still wondering if we can get any open source driver to work for the EGI amps and basically bypass NetStation. But
to try to get over this problem of the company closing down.
Well, that's part of it. I don't know if you saw. I mean, for those who are interested in high density systems, Philips Neuro is going to be closing down EGI, I think at the end of this year, but with everything that's going on, that might be delayed. And yeah, so I posted for Oren, who was asking about this, that, there does seem to be, I'm not sure how Brain Products is making a sponge electrode net, given that I thought Philips bought EGI for patents, but anyway. But it seems to be an alternative, and all you'd need to do is change the connector to be a Hypertronics connector, and it should work. But anyway, Jaden, is there anything else you wanted to show us, or are there things that you had issues with you want to talk about?
So nothing in particular. I guess the one thing that I'm still working on is just getting a good pre-processing pipeline for all the different notebooks. I have the N170 working, which I think should probably have the P300 working as well. I just need to actually record my own data for that and run it again. But I was having some issues with the SSVEP for myself. But I also realized that I think the first time I ran it, my stimulus presentation was off a bit, so I needed to rerun it again. I just haven't had the time with the amount of classwork I've had.
Sure. Well, yeah. So, post anything in Slack.
Yeah, I'll
certainly
be more active now.
A couple of these people who could definitely have been in the guts of the EEG notebooks. If I don't know how your Monday mornings are, but potentially you could join us in Paris for talking with the developers.
What time is that Pacific?
So I want to say it's 10:15 because I think he does it at 7. I think he does it at 7:15 CET.
Okay, I've got class at 11:30, so I can be there all the time before then.
Cool.
Yeah.
Okay. Well, thanks, Jaden.
Yeah, of course.
That's awesome. And yeah, really appreciate your contributions.
Yeah, I'm happy to be. I'll be much more active now. I'm glad to actually, because I'm kind of the only person working on this stuff at all at my university and around here. So it's nice to be more active with the community.
Well, and I mentioned this to you, but Yannick is on, and he can, if there is any interest you think in a student club there, Yannick's the person to talk to.
Okay, yeah, I think there definitely is. It's just that not enough people even know what BCI is at our university. It's a little old school.
Well, it sounds like a good control theory group, though.
Oh yeah,
that's cool. Hey, Yannick, while you are on, would you like to talk a little bit about the epilepsy challenge?
Yeah, sure.
Yeah, that would be awesome.
Yep. Hi, everyone. Yannick Roy. I'm obsessed with neurotech. Most of you know me through NeurotechX by my obsession. That's what I do. That's what I like. That's what I talk about. And NeurotechX recently collaborated with Novella Neurotech, which is a startup. Used to do more invasive. They want to go non-invasive. They are interested in the big brain data space, and with TUH, Temple University Hospital, that recently released. Well, it's been kind of like released for a couple of years, but they are increasing the number of available data every year, and now it's becoming kind of a quite a big data set. If you look at the full corpus, kind of like 1 terabyte or something like that, the full thing. But there are different sections of the data set that you can download. And with Novella Neurotech, NeurotechX, and TUH, we've just launched the Naraka challenge for epilepsy. It's a 1-month-long challenge for seizure prediction. We're trying to leverage deep learning and big data sets. I was personally interested because last year I published a review paper on deep learning for EEG, reviewing 150 something papers in the space of deep learning for EEG, trying to see where it's going, what people are trying, CNN, RNN, autoencoder, and kind of like what are the trends, what's working, what's not working. And while doing the review paper, we came across different data sets that very few people are aware of, and more people are interested in exploring AI and deep learning for EEG. So by launching this competition, we're hoping to expose more of these big data sets, putting a bit of a cash prize at the end, and just bringing more people trying new model, new approaches, being open source. So if you go on Slack, actually on the NeurotechX, well, in the main channel, posted recently, but I'm just going to post it again in the SF channel. But if you go, well, on Zoom, actually, let me put the link of the competition, Nereka-challenge.com. And
okay. I've got it. I've got it.
Oh, and was that my paper that you put
yes, of course.
The archive? Damn, you're on top of things. Love it. Could have put the peer-reviewed paper, but okay, the archive will do as well.
Okay. Yeah.
No worries. So yeah, so the challenge open to every and anyone. So you don't have to be a student, a researcher in the space. If you have some skills in machine learning, deep learning, and want to play with big data sets, the data set that we used is 57 gigabytes. So we didn't go for the full package because people at home won't be able to download like a terabyte of data, most likely. So 57 gigabytes of the EEG data is quite a big data set. So that's a lot to try deep learning and cool approaches. And 1 week prior to the end, so April 24th, we're going to be releasing the test eval data set, which is another 10 gigabyte for the final exam of your model, if you will. Where we're going to test and you send the results on that. Basically, it's labeling seizure. So identifying the start and the stop time of each seizures in the data set. So very exciting competition, I think. We're excited to collaborating with these two entities. If there's anyone interested in deep learning, EEG, epilepsy, the competition, feel free to reach out, talk to me either on Slack, right now on Zoom. If you have any question, be happy to answer. I don't want to just hijack the call, but if you're interested, definitely happy to continue the conversation. On Slack, there's the channel called Naraka Epilepsy 2020 as the official channel. So if you want to go there and if you have any question about the data set, deep learning, head over there and find also other people if you want to participate with the team. I know that earlier today, someone asked if some people were looking for a teammate for the challenge. So if you don't necessarily have other people or would just like to join a team, just go there and ask the same thing if people are looking for some help, and you might end up in a team finding nice people and tackling a nice challenge while you're stuck at home. That was my quick spiel. If there is any question or an interest, let me know.
Yeah. Anybody have some questions? I mean, there's a lot to dig into. These challenges are still quite a bit of work, but
I have a question, Yannick. There's other stuff than epilepsy in the Temple data set, right? Or they have like multi-label. So we digged into that a few years ago, and it was a bit of a nightmare. Like you go through that, you get the clinician notes for every patient, and the clinician notes you can kind of use to assemble kind of comorbid symptoms, and some patients have got other things in epilepsy, and you can kind of like compile interesting combination. You could study kind of multiple variables, basically. Do you know if that's been like organized by those guys beyond just kind of sticking it all online? Because that's where it was at when we were looking at it. They were kind of sticking it online, and then we were going through and kind of giving more metadata on like a subset of the patients. But it seemed like there was a lot more, a kind of more richer set of samples, a set of labels there than just, seizure, non-seizure epilepsy patient.
Yeah, as I said, the full corpus is huge, and there's a lot of things, and it's kind of broken down also in subsets, if you will. So the corpus that we are using is the seizure one. So it's focused mainly on seizures, but there are a lot of pathology. So I know that the group, Tonio Ball's group, is doing some deep learning for pathology and other things. There's as you said, kind of like the full the medical record from people over there. It's kind of like written English kind of reports. So there's way more than just seizure, but we're focusing on the subset called actually seizure. Exactly for that. But I know that there's if you go on Temple University, if you just Google Temple University data set, or I can put the link. Oh, yes, someone. That was the rsync command to download.
He wants to just cut right in and get the data without going to the website at all. I like that.
Don't look. Just download the whole thing, and later you'll realize that you just downloaded one terabyte of data. No big deal. But yeah, if you go on the Temple, if you just Google Temple University dataset, on the homepage, you'll see the different subsets of data. So if you're interested in other thing than pathology, then seizure, you should find some useful data over there.
That's awesome. Yeah, John, so we've done some of the NLP work that's necessary for reading electronic health records. Is that the kind of, I mean, is it at that level where you'd actually want something like that?
I was curious whether they'd done more in terms of organizing the data, kind of breaking it up into. Yeah,
Gotcha.
there's probably, I think the answer to the question is, John, just go look at the website rather than ask a question.
I'm more aware of the epilepsy side of things. The data set is fairly big, but yeah, I haven't explored all the other sub data set of that big corpus.
And I posted Tonya Ball's paper earlier, Yannick. So or at least the archive one, yeah. Terrific. Okay, so next up, we wanted to switch gears a little bit. Well, sorry, John. Hey, do you want to? I don't actually want to get us off of EEG notebooks yet. Do you have any updates or any?
Yeah, I can say what I'm thinking right now. Like, so we had a discussion about this, came up a little bit last week, and we had a few discussions back and forth on a few different Slack channels. But the bottom line is, so EEG notebooks is turning out to be a useful tool for a number of people. We understand it's not like perfect, but it's turning out to be a useful tool, and people are kind of there's like break-offs and reaggregations, which present interesting possibilities. But one of the kind of separately to the, if you like, kind of core development tasks involved in kind of pulling together, you know, like this brainflow stuff, for example, and Kyle's big additions and all of that. There's this question of data management. And this strikes me as an important thing to try and kind of figure out a general strategy to kind of commend to the community, as essentially like, because we haven't done a whole lot of like extensive systematic testing for all of the stuff. I mean, Kyle's done a lot for his new things, but it's quite kind of all over the place. But there's a lot of people, the bottom line, what we do know, and I know for sure, and I've done this, a lot of people have, is that there's lots of people who are generating data, and then it probably is kind of sitting somewhere and not being used. So, and it's certainly not being kind of aggregated at a, you know, community level. So the thinking was just to like, what is the strategy that we should be thinking about in terms of having some kind of system for saying, hey, you know, the neurotech community, the kind of scientists in doing academic research, anyone who's doing these things, right? To the extent that they're using like the same paradigm, and there are variants, but to the extent it's like, this is the same experiment done in a bunch of different locations, can we kind of figure out what a good way of aggregating this data is? And so that was like the thinking. Now, in terms of the answer to the question, I've got two kind of parallel lines, I think, that seem like they provide useful parts of the solution. One is just to keep it simple and just say, look, we're going to keep it how it is with the folder structure as it is, with like subjects, session, data, and just have like essentially like a Google Doc and maybe a folder, and just say, look, if you want to help us out, stick your data in this folder. There's this, you know, Google Drive folder, right? That's like the simplest option. And that probably, it wouldn't be a bad idea to get in place just so it's available. A more kind of sophisticated version of that, and I think this is where we want to go to, and this is what I've been looking at right now, and this is what I was talking with Morgan most recently about today, is having a distributed DataLad super data set. So DataLad is a Git Annex based tool that is like allows for basically large data set management and sharing and stuff like that, kind of informatics type stuff. So the way this would work is, I think, now this is where I'm at in terms of how I think this would work, is you can have a super data set that has sub data sets, and what you can do when you want to like install, as in like pull the data, is and essentially it functions like sub modules, like Git sub modules. They're kind of Git annex repos inside other Git and Git annex repos. So I think the way to do this is the following: is we have like for each experiment. So let's say it's M170 paradigm. We have a super data set, and then within that there is a sub data set, and each sub data set is some amount of data that's been recorded by either an individual or a kind of group of people at a certain site, and that would be, you know, multiple subjects, multiple sessions. And so what we'll end up with is we'll have, say for N170, what you'd have at the top level is the and then these can be kind of hosted on GitHub with you can put you can have like not a fork, yes, just clone, like a clone of the top level Git annex repo on GitHub, and that could be like where you look, and what you'd see is N170, and then inside that you'd have multiple folders. Each of those folders would be the kind of contributed data on N170 from each of the either groups or individuals who've provided the data, and then that does the job of A, like organizing stuff, and B, having a mechanism for pulling stuff in a coherent fashion.
Yeah.
So that's the thinking. In practice, what it requires, what I'm just trying to figure out first is the practicality of like the data lad commands to kind of set that up. Yeah. Oh, Kyle, cool. Yeah. So Kyle's kind of showing some stuff.
Yeah, Kyle's.
Yeah, great. So just trying to I'm just looking into the data lad part of that, and then there are other things that we need to kind of figure out, one of which is a consent kind of mechanism as well, which I think probably needs to be in there, like some kind of Google form that we point people to make sure we're doing things in a kind of kosher fashion as far as we're able to.
Sure.
In this slightly out of the lab context. So at the moment, what I'm doing while I'm listening to you guys talking and all of that is I'm going through the data lab documentation and just playing around with trying to create a super data set and install sub data sets inside it, just as some like example things, not with some EEG data yet. And then hopefully that gets figured out, and that will be part of our approach to trying to have a kind of systematic proposal for, you know, the community of users for what to do with the data that they generate. I do think that the simpler option of the folder is definitely going to be something we want in the meantime, because it's not clear to me that have this. It's a little bit fiddly, this data lab thing. So I'm not sure if it's going to be immediately easy and usable kind of very soon.
Sure, sure.
But you're right, it should be a hierarchy, because I might run 100 people with subject numbers and you might run with the same subject numbers, and you want those to be sub components of a bigger.
Exactly. Yeah, I thought the experiment level is the sensible kind of top of the hierarchy, and then within that, you know, you have sites that could have, it could be just one person, one data collection session, and it could be, you know, you with 500, and they would all appear as sub data sets. Yeah.
Well, I'd love to get Jarek on and to talk about this, or Michael. I mean, either one of them, depending on their availability and which time zone hack night they want to hit. It'd be great to have them on, because I know that they're dealing with this, you know, maybe not EEG, but they are this kind of multi-site, you know, data sharing, data consumption, you know, as soon as it's on a disk at some site, it's known to the other sites, even if they haven't necessarily transferred it.
Right.
And, you know, and a lot of metadata is too. So,
and it'd be interesting to see if there's other examples of this type of problem, because this is slightly different to your standard large data set sharing job, which is typically, you know, large data sets from this lab and this lab and this lab, and they may be like thematically related, so they get grouped together for that reason. But we're doing something very kind of distributed and quite different.
Yeah, I have some experience with dealing with this kind of nonsense. I did this with like music metadata and music APIs when there were like a lot of companies out there before Spotify bought them up and stuff. So yeah, we can talk about some of at least some of like the holistic or like struggles that I had in that process, and some of the things that I wish people did differently back then and all that kind of stuff. So
great. Yeah, glad to hear that.
Yeah, happy to connect with you on that.
Thanks. There also may be similar activities going on in psychology. Like Kyle, maybe you know. I mean, there's a lot of, you know, online data set kind of psychophysics, cog-psych type paradigms, like, you know, Pavlovia and MTurk. And so I suspect that there's activities in that area, but I haven't seen any kind of this integration type, you know, problem being raised, but it could be being discussed elsewhere in a similar fashion.
Hey, I have a question about if we're collecting all this information. Just a quick introduction. I'm Nick. I'm new to NeurotechX, but when you collect these big data sets, is that under HIPAA compliant? You have to like anonymize the data somehow? How does that work?
No, I think the way we do this, well, firstly, we do need to have consent for certain things, right? From my point of view, like, you need consent to do certain kind of scientifically signed off things like publish.
Right.
Now, exactly what the consent needs to consist of is not at the level of like HIPAA compliance and not anonymity. It just needs to be like they know what they're getting in for, and it wasn't unethical. Okay. Now,
we need informed consent. Yeah.
Yeah. Now, I'm pretty sure that within the, I'm quite sure I probably need to run this by like the ethics board. In fact, that's exactly what I need to do. That what the scenario we're talking about here is kind of people who are volunteering their data to be in the public domain. Now, it's not any different, as far as I can see, to just general open data kind of consent, but we're kind of managing it in a slightly more like completely open kind of fashion. So there are a few little bits that maybe we need to think about whether there's like deviations from your standard consent form, but it's not. Yeah, and anonymity is one of those questions. Is like what level that needs to come in, because it's not, strictly speaking, unethical to allow people to put their data in a public domain and do it in a non-anonymous fashion. But whether we should be doing that is a different question.
Yeah, I think you'd probably want to anonymize it, but it's good to know that you don't have to be as strict as HIPAA. So
yeah, I mean, the way to do it is going to be like every kind of data set. So it'll be like, you know, Kyle collecting his stuff, or the recommendation will be whoever's doing some level of data collection, you will have a kind of private key, so like Excel document basically, that has UUIDs, like, or subject numbers or anonymous IDs linked to the subject information, and that just stays with the person who collected it. That doesn't go into the public domain. The only thing that goes into the public domain is the subject numbers. So that's also part of this, you know, information package that we need to put out about how people should be doing this.
Yeah, I mean, And, you know, I think, well, I would be curious for, you know, groups like GazLab, what they're doing, that because they are collecting at home, you know, so it would be, yeah. So whether the people are actually just sending things back over the web, or they're storing things locally, is one of the things that came up just in terms of, you know, security and privacy. But if I think it'd be great to have Data Labs folks come sometime to just talk about what that is. Did you want to talk about EEG bids at all?
Oh yeah. So that's part of it as well, right? So yeah, so that kind of comes along with DataLad in a way, because it's not mandatory, but the encouragement with DataLad is, in neuroimaging at least, is to have data sets organized according to the BID standard, which is just a standard file folder nomenclature that allows, it makes it easy for people to kind of do analysis on data if everyone's naming them the same. Yeah, good. And Kyle pointed out that it'd be a good idea to use M&E bids with EEG notebooks, because the data is being put into M&E objects already. So thanks for that, Kyle. I took a look at that, and I think you're right. And the kind of secondary question that this kind of raises is, and I think the answer to that is we'll probably end up having two parallel versions of data storage for EEG notebooks, or it would lead to one that's BIDS format and one that's the current format they already have. And I guess the thing to do would be to we'd have both in parallel, and then maybe if we feel like we want to drop the non-BIDS one eventually, then we do. But I don't want to kind of rush that, because that would be more, I don't think we would achieve a lot by just converting everything to BIDS right off the bat. But we can certainly kind of be looking into that as part of this process. Yeah.
Well, so I'm certainly, like, I'm in with this data set from the machine learning repository that I think is a good example. And we, you know, together with Simon, we converted this to EDF. It was just very old text data, but I'd love it to be with all the right, you know, auxiliary files, such that I could then bring it into either SPM or EEG Lab or Field Trip, and, you know, they would know what to do with it, or they would know, like, what the trials were and things like that. I mean, I assume that's the goal of EEG bids, is that, you know, if you're in that format, like, all tools should be able to read and get that kind of, you know, experiment information. And
I mean, it's a good question as to what the priorities here should be, whether it's getting that, do that first, and then do this kind of data set organization, like, you know, data set collection recommendation thing. Both of them are jobs. I guess I was kind of thinking, okay, which of these things do I think is going to get done first? But ideally, like, different people do different jobs, but if people think that that's the first thing that should happen and everything else should fall in behind, then you know, make that point. I'll listen.
The way I would make that particular point is that if you install DataLad, you know, essentially via pip, and you install M&E Lab, right? You could, if you use the Muse and you saved your data in this EEG bids, then I should be able to just bring it into M&E and start processing it as if it was, you know, regardless of how many channels it has. And I would, you know, at least have some kind of, you know, some kind of native M&E support, if that makes any sense. The DataLad part is if it's saved in that particular folder or directory, then it would also kind of, like, the the metadata about that recording would be passed on, or could be aggregated somewhere on the network.
Yeah.
And
yeah, like I think we could do these two things and think about these things in parallel.
Yeah. So, but anyway, at least it's clear the direction you want to go with EEG notebooks.
It's a direction. It's one of many, but it's one that I'm kind of thinking it through, and then I'll try and kind of shout about it and bring people in over the coming weeks.
Okay.
When I have a clear recommendation for how to go about it.
Okay. And is there anything else? I mean, I guess nobody at this point has had a chance to try the Mac version of EEG notebooks, I take it, which is.
I actually haven't even tried it since John
Okay.
merged that fork, but we probably should.
All right. Okay. Well, then I'm going to put that down as a semi action item. I somehow skipped doing that myself this week.
Can I add an item to the agenda?
Yeah, please.
I wanted to just do a demo of this little thing we've been working on to combine muses from multiple streams into one place.
Okay. Yeah.
But it doesn't have to be now in the agenda.
It's not a bad time because we're going to change tack and get into NERS, which is of course near and dear to your heart too. But if you want to just you want to show us that quickly and then.
Sure. Yeah, it won't take long. So maybe you guys saw the EEG EDU website we made this year.
Show us a little because Xavier, this student from Montreal, got in touch last week, and he said that he'd had some really great experience with EEG EDU,
cool.
Connecting with the Muse, and he wished he'd known about it earlier for a particular student project.
Yeah, so this is I'm like a big fan of keeping continual simplification of these topics, and EEG notebooks is already the simplest thing, and then we wanted it to be even simpler and less troubleshooting and easier for people that have no coding background to kind of get in. So we created this website here, and then this is partly in collaboration with Yannick and Neurotech EDU, who are looking for ways to scale up teaching from EEG notebooks to more people. And so this website actually uses web Bluetooth to connect to a Muse. I think you guys can see this now, right?
Yeah.
And so you can stream mock data or a Muse data, and it has a series of modules, and the last couple are kind of part one of, I think, what's going to be a kind of EEG EDU level 2, where this is running a full experiment in the browser, so it can pop up and give you an oddball task and save a CSV file with the raw data and markers of where those things happen. But it's not as effective as PsychoPy or whatever EEG notebooks is using. I think it's PsychoPy or so the timing's not good. It misses markers. We were going to test that this semester in class, and then shit hit the fan.
Sure.
So we just stopped after the 6th module. So we have a big data set of eyes open, eyes closed now that I shared the other day on Twitter. So this is good, and we did it in a computer lab with 50 people. It was really, really cool. So the students got in pairs and collected data on each other. So we collected 80 subjects of data in an hour in an experiment, and you can then save these CSV files. So then it's not unfeasible just to link up the two ideas to think about converting this in the same way into this structure that we would create, so people that might run an experiment like this could save these files in the same format as if they had made them in EEG notebooks. So I don't think they're separate paths. They're kind of the same paths, but I think this is one less level of complexity taken away from it. But then once we all got stuck inside, we were thinking about how can we, and we've been trying to work on ways for performances with lots of people combining their EEG data. My brother, who is working on the website, is a comedian and wanted maybe feedback from the audience's brains from a big group of people. And in the classroom, we might want to collect data from our students and monitor what they're doing. So we wanted a way to combine a bunch of people's data. So I'm going to just show you, if you want to get this running today to see how it works, you can clone the notebook. So you don't have to make the notebook and make your own website. You can go to EEG.edu for that website, but we've, there's a fork in here. That's not good. That's okay. So this is on the masters, just like what's online right now, but in this branch remix 2, no. Check out remix 2. I can yarn build. Okay. I'm sure that I'm gonna screw this up. Maybe I can figure this out. Okay, so what the idea is we're gonna have multiple Muse clients that get created and stream their data into a socket. And we're gonna have a server that collects those sockets together in one place. And right now it's local on my machine, but we're a couple days of trying things out, hopefully from getting it to be multiple IP addresses from all over the world that can then stream data into one place. So clearly I shouldn't have uninstalled all of this. So maybe I can show you what happened in the backup I made.
So Carl, do you have some kind of like real-time, user subject interaction brain feature paradigm?
Close, almost. Yes, kind of. I have an example here I'm going to show you. Sorry, it just is building the thing now. So right now it's set up like I'm a teacher and I want to watch all my students' brain activity. But just as well, we could be feeding in different streams of data and getting it to control lights or pictures or so. I think that's everything I need. Oh, maybe that should have been a node start.
I only got some experience with this trying to get Neurodora working.
Okay, so let's try that. Localhost, yes. Okay, so then if you've done that thing that I just did, which I'm not quite sure even what I did, you can go to the local host right here where it's served, and there's now only one module, and it's just going to take the spectra and it's going to stream it with your username into a socket. Then you can go to localhost/together, and every new user that comes on and does this, which could each connect to a different Muse with this button, every new user is going to show up on this dashboard as another box. So that's as far as we got before like the virus really got crazy here and we all had to change our lives. But our goal now is to get this so that all 10 of us or 20 of us right now with a Muse could all stream into a website together and do neurofeedback as a big group or control some sound. Or we're thinking like a chat room is kind of the best thing to shoot for in this current climate. A mood ring chat room.
Yeah, no, that's awesome.
Yeah,
that's actually
that's really, really cool.
Yeah, and you know, the Reed Montague's hyperscanning just uses chat. By the way,
cool.
You know, so you can use chat and synchronize, you know, potentially synchronize, get interesting social interaction data.
Right, from not in one place even, in theory.
Yeah. So they were doing that, you know, from one scanner in Blacksburg, one scanner in Roanoke.
Right.
Yeah.
Okay, let me stop sharing here.
That's awesome. And yeah, appreciate the EEG EDU demo. In terms of the timing issues, because that, I mean, certainly we talked a couple of weeks ago about Cloud Brain and you know, similarities with Cloud Brain. This is not trying to handle anything in a it's not trying to capture delays or anything.
No, currently it was like the easiest way we could think to do it. So it's really clunky. It's like it's a P5.js sketch, I think, inside of a component of our website. So yes, we could probably do better than we're currently doing. We could try to integrate some of the existing software there is for porting your Python scripts into a website experiment.
Okay. Well, I know Andre's asking about your, you know, your back end and, you know, what you, I mean, I'd love a chance for you both to share what you know, because Andre's definitely trying to look at some things given his background in industrial control system and, you know, their synchronization. And so.
And Andre, do you mean in the EEG EDU website, or I think you mean in the new tool, the remix thing? Maybe not. Just asked and leave. Okay, yes, the new tool where you can connect together. Yeah, it is all in that Remix 2 branch, but it's pretty new. It's what my brother made recently. So, but I think it's all open there. But maybe I don't understand your question.
Well, if there's any specific
we'll talk.
back-end services that should be discussed and split out, please talk about them and then post relevant details in either, I guess, the EEG EDU channel.
Yeah, I don't think anyone's ever posted there. We would love someone to post something there.
Okay. Well, again, if Xavier's not here to pass on his warm feelings about it, I will give them to you. So hopefully he'll be back and tell us how he's getting on, because he was yeah, I'm not sure what he'll end up doing for his project. Hey, before we get off of EEG, hey, Nick, Muse 2 problems, did you get them solved? And if not, can you follow up with Alex while we're talking? Follow up with Alex in chat.
Yeah. So I found the app and also the Mindful Viewer, whatever it's called, the like paid version. I basically haven't really touched it too much yet.
Okay.
So what I did was I tried to go to Blue Muse and like download that from the GitHub, and I could not figure out how to install it. But I think just with some more concentrated effort, it'll
sure.
find something. Well,
so let me then just say, in lieu of other instructions, try the EEG notebook instructions and see if that helps at all in terms of navigating that. And
okay.
And certainly in terms of feedback, we'd love to know what didn't work in the EEG notebook Windows specific instructions. Okay.
Yeah, I think they might need. They might need updating actually, the
It totally
instructions.
does.
I don't know if they, because there's the installer now.
Yeah.
So basically, Nick, like you download you download the release, you unzip it, and you go into the folder, and then there's a PowerShell script called install, and you right click and run with PowerShell.
Yeah.
So when I right click it, it doesn't give me the option to install. It just says, do you want to open this? And I say yes. And then it's like, here, we put it in a notepad for you. And I'm like, no.
You want to run with PowerShell, or run in with DOS prompt or whatever, but just run with PowerShell.
Run with PowerShell. Yeah.
Yeah.
Okay. Yeah, please, everyone, we could use feedback for the documentation, and even better, updates. So if you're going through an install, or especially if you're unboxing new equipment, it's a great time to make a contribution by updating a little bit of documentation.
So what I'll do is I'll try to install it once I'm done eating here, and I'll give feedback in the chat if I can figure it out.
Okay. Thanks so much. And anyway, just didn't want to leave you hanging. Before we change tack, anybody have questions for people? Anybody have anything? Do we have any new people who'd like to use this chance to introduce themselves? I can, not to put anybody on the spot, but there's definitely some people I don't recognize. If Amanda or Margarita or John Ann. Oh, John Ann's John Nolte. Okay, sorry. Hey, John.
Hey, how's it going?
Hiya. Any thoughts? You're just Harris. Anybody? Excuse my dog.
Anyone from Toronto on the call?
Getting to know what you do. I'm fine. I'm Margarita. No questions yet. I'm trying to figure out what guys do want to do.
No problem. Certainly not trying to put you on the spot. Just wanted to make sure we gave everybody a chance. And
anyone from Toronto on the call? Just wondering.
I'm in Hamilton right now.
Hey.
Hi, Ian.
Hi. So yeah, I'm a Master's of Computer Science student at Ryerson University, and
Awesome.
I've got Open BCI, and I'm working on I'm starting ERP research, and I've got a class this semester called Computational Methods in Psychology, and so I'm trying to make some inroads there, yeah, working on my master's thesis over the next 2 years, if everything goes back to normal.
Yeah. Well, thanks, Ian.
Cool.
And,
nice to meet you.
Yeah, great to have you. So we're gonna change tack. Anybody who'd like to have introductions, please add yourself in the group chat so that we can take a little time. It's no trouble and there's no pressure. So I just wanted to switch us to talking about near infrared spectroscopy for a little bit. And so we've got Josh B. Is it Brewster? Who's going to show us his, would I say Hedgeduino?
There you go. Yeah, Hedgeduino. Hold on, let me share my screen here.
Hedgeduino? Yeah, sure. You don't have to jump in straight away, or I just wanted to ask Kyle. Kyle, what would you? I had this paper from 1993 of Arno Villringer as like a kind of foundational NERS paper. Would you have any other suggestions for Josh and in terms of introducing people to, you know, what NERS is sensitive to? And
yeah, the Joseph Culver at in St. Louis. What's the Washington University? If you Google Scholar Joseph Culver, but this guy does like the best full head imaging with NERS and does retinotopy with NERS as well.
That sounds cool.
And he's kind of from he's in biomedical engineering.
Yeah, so I mean, it's the same Culver that used to be, sorry for my dog, that was in David Boaz's lab.
Yeah.
Like 20 years ago. Yeah. Okay. Yeah.
So some of his more cited papers, but also some of the newer papers are really like state of the art for what you can do if you have a hundreds of $1,000 system.
Yeah, right. And so just to give you a heads up before and then we'll let Josh talk, but we'd love to know, you know, we'd love to get at like what are the differences in that hardware? What's it allow you to do? And especially when we're talking about scaling up to multi-channel data, right? So yeah, there's some great I see some great references here in the Culver. So yeah, Michael, did you want to talk just a little bit about example data sets for people to play with?
Yeah, we can. Let me pull it up here. The one
you said that you found some stuff in M&E directly.
Yes, so I found kind of an M&E little Jupyter Notebook project by a gentleman. Let me remember his name. I think his name was Mark. But what was nice about this notebook was the other data set that I'm going to link. It's from the Berlin EEG data set. And that one it's got a lot of good data, but how they export the data itself is actually quite messy. And so there's a ton of processing that's going to have to go on to even get at it. Let me find this guy. I have it up here. Oh, here it is. Right. So this data set is nice because it has just like a single example, a single subject. It's in the chat now. But all the data is kind of like parsed. So you're just getting like the raw oxygenation feed.
I'm getting just a sec.
Sure.
I was getting a second URL in there. Somebody can, sorry, or for some reason it's going from Zoom to, yeah, there you go. Thank you.
Yeah. So this has the data set that it provides is really just one participant, but you know, it's a single NumPy array that you can work with all the chain. It's all processed out already for you, which is nice. And it does a I haven't I've gone through a bit of it in terms of running it all. It seems to work fine so far, but you know, I think it's a pretty decent code base to start with using M&E as well.
No, that's awesome. And so if you could post a link to that in the open NERS in the open
sure,
NERS
yeah.
room, that would be awesome. And
let me link the other one too. I'll link this in the Zoom chat. This is the Berlin data set. This has EEG as well as NIRS.
Right.
There's a sign-in kind of open access policy, so give them an email address, and it'll give you some description of the data. I'm happy to go through at some point with, if someone's interested in looking at this NIRS data. I would love the support to try and make heads or tails of how we organize this stuff.
Sure.
Mostly because it's saved as it's a MATLAB object, but you know, it's an embedded array without labels for any of the structs. So you kind of have to, even though it's giving a description in the next part of the portal, it's still not really that clear what's going on. So
okay.
Yeah, it's a bit of a mess.
So I mean, that's great feedback. Thank you. And you know, the other thing to point out is that this EEG NIRS data set is already, the EEG part of it is already processed as a part of MOAB, because it's a motor imagery experiment. So if you run MOAB tests, or you know, MOAB-run, you should get that EEG data processed and saved in an M&E data directory in your home directory. So I think it'll be interesting. Did you see how many channels is in the Berlin data?
I think there were like 20.
Okay.
Up to 20 to 40, I think. That might actually be the other data set that had 20. This one has about 20 as well. And Suhas, yeah, there are NIRS. I mean, Josh will talk about his hardware, but definitely are systems that are cheap, if not cheaper than EEG out there right now.
Yeah. So I hadn't given Kyle a heads up that we would be necessarily going through all of this, but so it doesn't have to be tonight, but it would be great, Kyle, to get more references that you think are good in terms of, you know, people explaining, you know, what you're getting for like each, you know, power of 10 price increase, et cetera. And not that it's necessarily more expensive, but you know, what are the hardware requirements that that are era specific? But so we're gonna get into. I'm gonna give Josh a chance to talk here, just to say that, you know, NIRS, for those who aren't familiar, is this other technique that is related more to fMRI. Or, you know, I think this is a really great opportunity for people to play with a sensor that gives them something that is, you know, is dealing with basically the neurovascular coupling and these measurements of oxygenation, hemoglobin oxygenation. So with all that intro, Josh, would you like to, sorry, let me stop sharing. You'd say a little bit about your background, and then please show us HED-Duino.
All right, sure. Okay, can you see my screen?
Yeah.
All right, cool. So hi guys, I'm Josh. I'm from Fairbanks, Alaska. Well, I was born in Juneau. I'm living in Fairbanks, Alaska right now. So I've been working on this little project here. It's an FNIRS device called an HEG. It's really basically a pulse oximeter, but sensor is spaced about 1 inch from the LED. So what that allows you to do is to see slightly deeper into the scalp and to the surface of the cortex. And what's cool about this is it's kind of the $5 solution. And the way I got into this project was I was just really curious about HEG and learning about neuropsychiatry, and I was learning about brain computation too, which it's weirdly relevant. And it kind of led me into wanting to, use this device. And the only guy in town who had it was this therapist who charged $200 an hour for the privilege to use it, and that kind of blew me away. So I made a bet with him that I could do it for less than 20 bucks, and a couple months later I did it for less than 20 bucks on like a little Arduino Nano, and that was cool. And I started working with this 3D printer group very briefly, and through that I learned about microcontrollers. And I have a mentor, and he's in North Pole, Alaska. He's this really rad blues guitar electrical engineer, or blues guitarist / electrical engineer. And he showed me how to, we basically reverse engineered Herschel Tumim and Bob Marsh's patent on their HEG device. So back in the 90s, they developed basically the original one of these. And they were also trying to explore low cost solutions for FNIRS devices. And they also Herschel did a lot of the pioneering work just to get people interested in this field. So I was able to take their work, with their permission. I'm friends with Bob Marsh now, and Stephanie DuPont at the Biofeedback Institute. They helped me come up with this project here. So what I did was from there, I was able to develop basically an IoT HEG, and it's an ESP32 board that you can get for $4. And I designed just a very simple PCB, and on the backside is an ADS1115, which is a 16-bit analog to digital converter. So it's able to take it's able to take the signal from the photodiode here as the LEDs are flashing, and then we just compare the ratio of those LEDs flashing, and with that we can do pulse oximetry. Now, my device has a few issues, so I'm not able to get very reliable pulse oximetry data. But even at 15, 16 bits, I can see pulse clear as day, and I can start to infer things about the blood oxygenation of, supposedly your frontal cortex based off the spacing of the sensor. So all pulse oximetry is you flash a red and an infrared light into your skin, and basically the ratio of red to the infrared light being reflected back is proportional to the ratio of oxygenated hemoglobin in your blood. What's cool is with the signal, you can even see the pulse from your heart, and you can do a lot of very interesting things with this information. And then you can also see information about not just your pulse, but like the non-moving tissues and just the general perfusion of whatever tissue you're measuring. And for us, we use basically the simplest metric from pulse oximetry, and that's just the ratio. We could see heart rate, we could do heart rate variability with this if we wanted, but what we're really interested in is just the general perfusion of the brain at the sites that we're measuring. And the reason this is because of a phenomenon known as cerebral hypoperfusion, and also how hemodynamic response is involved in our cognitive abilities, etc. And the gist of that is, your blood is providing all the fuel for your cells, and it's cleaning out all the crap that's being left over. So that's a really essential process to be working. And what we find is that when people take head trauma or experience emotional trauma and or a severe stress, is that we measure that in parts of their brain that it'll become hypoperfused, or in some cases overactive. And what's cool about this is that this is a very sort of clear-cut measure of some kind of dysfunction. So that becomes a really good thing we can work with the person, and supposedly help them re-normalize their brains and hopefully their psyche. Now, where this was used originally was in kids with ADHD. One of the things that was found in MRI and brain research with ADHD patients was that certain parts of their frontal lobes would have hyperperfusion, And so what they found is that doing like attention training exercises with the HEG, where you're able to see whether your average, blood oxygen levels are increasing or decreasing, the user was basically able to get a grip, and they're able to start to control that internally just from the feedback they were getting, and doing the breathing and concentration exercises, and essentially giving that part of them direct attention. And then this became, it turned out to be a fairly useful thing to use alongside other ways that other classic ways we treat ADHD, and now it's reaching into like PTSD or depression, or there's autism research happening, dementia, all kinds of very interesting areas, which are, they affect a lot of people.
Josh, can I ask a technical question?
Oh yeah, go for it.
So why are you using just the ratio as opposed to trying to estimate the absorption and compute the Beer-Lambert equation?
So I could. So like I said, on my hardware, it's not particularly reliable because it's just my work. And all you really need though to infer, just infer the average perfusion is that ratio. From there, you can like separate like the pulsatile flow and the non-pulsatile flow, and you can look at the perfusion index or SpO2 or whatever. But it's not actually necessary to go that far just for training. And the idea of the HEG is that you're really just using this for training. And then what I'm working on though is, well, before I get to that, I just want to continue what I was saying before about just correlations with brain blood flow issues, and these being like comorbid basically with a lot of very common mental issues. One of the things that at the Biofeedback Institute that they would do is that after a few months of training, they would go pay to have some of their patients get SPECT scans. And generally what they would see was that after a few months of training, what they found is that the average blood flow in these patients, like in their frontal lobes especially, was increased. And that's interesting because the idea is that you're sitting there and you're concentrating and you're trying to increase this, increase the blood flow and the activity in your frontal lobe through the exercises you're doing. And then the idea is that this has like a lasting impact, because you could think of it as a type of exercise, where it's like literally strengthening and encouraging like capillary growth and response. It's very interesting, and I think it has a lot of potential. I don't know what other people really think about it, but just from what I've seen, and it seems pretty compelling. And you can interrupt me at any time with questions. I'm all for it.
Are you so you're able to do this using the HEG? Do we know?
Yeah. Yeah.
Okay.
So,
because I have both ADHD and depression, so if I can recreate this and test it, that would be awesome.
Yeah, absolutely. I mean, I even have kits I could send if you want. Just message me.
Yeah, great.
So.
Yeah, I'd
so,
love to
keep
going with the hardware specs. And
yeah.
Getting at the.
Sorry, this is just another couple cool pictures. I think this is just useful stuff to sort of have in the back of your mind, as like this is a part of you. Like your neurons require a ton of energy basically to function, and your neocortex is one of the most energy consumptive things in our bodies. And in order to reinforce this, we have these pretty wild capillary networks here. I mean, it's like really fills out the brain there, and then you can imagine all the gray and white matter in between. And so what I've read is that basically in resting state, your brain uses about 20% of your energy, and then under stress, you can be using up to like 40% of your daily calorie intake. And for me, that's really interesting to consider, because then you consider about, you consider that in parallel with the effects of stress on the body, or like cumulative things that are not necessarily good for your your body and your brain, and how easily this kind of system could probably go into some kind of dysfunction, you know, in any kind of developmental context. Really, it's a very sensitive, you know, recently evolved system. We don't understand it very well, and you know, for me personally, like, I'm very interested in the idea of that, you know, through these tools we can develop better ways to help people with mental illnesses. I mean, you know, I've had my own problems with depression, and I've understood it now in certain ways in light of like this kind of information, and it's been very helpful. And using HEG for me it's a useful sort of mind-body exercise in a lot of ways. And then there really does seem to be something to this brain exercise. So personally, I'm just an advocate in this. And then I got this hardware because I decided to sort of just go full on with the project of trying to just, you know, develop an actual product instead of just some cool Arduino thing. Because what I found was that there wasn't really anybody working on like a, you know, just a basic consumer-oriented device in a meaningful way, and trying to sort of bring down a lot of the, you know, the brainy science to just sort of useful, you know, useful things we should know. It's, for me, I try to say, like, there's things to like knowing how to breathe or knowing how to be present, that it's like knowing how to brush your teeth. They're very essential like tools that we use in our day to day, and to keep ourselves alive and healthy. And like something like the HEG is really good for educating on that and giving you this sort of direct connection to this, just by the feedback that you do. Now, so there's other devices out there. One of the ones I think you guys had Justin or John David Chubuk on with his Blueberry. Actually, he commissioned a prototype design for me, and I think he's been using that to then work on his actual, the one that's going to actually go in his product. I couldn't get my version working, but it had pretty good specs, so I hope he took it. And then the Biocomp HEG. This is a picture of Bob Marsh working on it in his office. I got to meet him. He's a really nice guy, and he gave me the thumbs up on my HEG, so that made me really happy. And his devices, sometimes you get them for $500, sometimes they're $1,500. I've seen them being sold by other people for up to $5,000 with like their packages. It's pretty wild. And this device, the Peanut HEG and the Biocomp HEG, like, I based the level of my functionality off of that one because that was the one I had interaction with, and that's the patent that I used to, you know, I use that to make my sensor design. And I just applied some things to make it, you know, it's an Arduino device, so it should be really simple.
And the number of sensors in the Soterix.
Oh yeah, so I was gonna that. So this is the NurSit, this is the Soterix headset, and there's like 250 sensors arrayed in this, and then they're able to use some tomography and noise canceling to like get, well, what they say is they get 0.4 by 0.4 square centimeter resolution of your frontal lobes, brain blood flow. And then this, oh, were you gonna say something?
Well, I was just saying, like, so do you know who Soterix contracted for that? Or, I mean, that's not in conjunction with like Neurix.
Well, see, I read about it initially from a Korean paper saying that this project was mainly happening in South Korea. And then
okay,
I remember I read about this project a while ago. I just don't know it off the top of my head.
It's certainly possible. I mean, I remember when their one device was just a TES device, and and it's actually not even TES. It's like literally just DCS. But they were the company that, you know, really pushed finite element modeling of that direct current stimulation. And they were also the ones that, you know, for a long time, everybody in electrical stimulation was using, you know, 5 centimeter square sponges. And they were the ones that developed an electrode that fit, kind of in the size of the Near Scout. So instead of using this big sponge, they were using a very small electrode, and it would actually fit in a biosemi. It would fit in a biosemi cap, which is a research EEG cap. Anyway, I'm curious. I see a few reports of this being used, and I'm just interested, and I was super interested in the papers that you had in terms of how they were interleaving sensor like emitters and sensors to achieve that high spatial resolution. It was very interesting.
Sure, I got those from Bio.
Hopefully, it can be done for less than 20,000, but we'll see. Sorry, please go. Please continue.
Quick question. So at what point is there a diminishing return in terms of like stacking that amount of sensors? So you said 200 something.
Yeah,
there's like 250.
Yeah.
So if you do that for like a EEG device in the forehead, I'm not sure that like at some point there is a big diminishing return. The value in terms of with FNIR's device, could you stack like way more than that? At what point does it become kind of like not relevant at all?
Well, I mean, so like hypothetically, right? The brain's it's moving blood around asynchronously, and then the like columns of your brain are pretty small. So I don't know. Like
I think
for this one,
the spatial resolution in NIRS is a function of the overlap of channels. So the more channels, the more intersections there are between them. And so as long as they all have slightly different paths, then you do get better and better spatial resolution as tight as you can pack them together.
Right.
And certainly like the bigger limit, or the big problem we had with EEG electrodes is you start getting them close together, you have to make sure that they're not bridging, or at least on the EGI ones.
And there are these problems too with NIRS. Yeah, you have to worry about the dynamic range of your sensors being able to pick up the near and far sensors.
But so I mean, this Josh's project, I wanted to be a real conversation starter about basically all the same issues that we have with high density and how to potentially solve them. And there's definitely some good follow-up papers that Josh can share with us on the Soterix medical one. So
sure,
to be continued.
So I was answering a different question than what I guess you guys were asking, but yeah, you could hypothetically, it's really as small and as sensitive as your sensors are when they're that small. Like you could probably hypothetically array these as densely as you wanted to get as fine a resolution as you wanted, using you're just comparing a lot of space, like signals spaced at different positions, and then you're just using that to try to cancel noise and fine grain until you get a something smaller than, like, you have to space the sensor at 1 inch, but then if you space a bunch of sensors around that one area at 1 inch, then you can average all that, right? And then that's whatever computed tomography at its most basic. So then there's the flat sensor NIRS devices, which are just using photodiodes, and then there's these optical devices, which are using fiber optic leads that they pull into whatever kind of converter that they use to measure that.
Josh, sorry, you're fading out just a little bit.
Okay, how about now?
Yeah, thank you.
Okay. So yeah, so these are fiber optic, which is another, this is like a much more intense way to do this, and much more expensive too. I have no idea how much this costs. You have to ask them for quotes, and I was a little scared to ask. But but you can see how they've arrayed LEDs here, and then they have in between, and then they have these optical nodes all arrayed out, and then they're using that to get similar like spatial data like you see with that NeurSit image. So okay, my hardware, again, it's based off of the original FNIRS patent by Herschel Toonam for his HEG. And his project was to basically try to make a low-cost device that he could do the brain training with. The patent itself is actually a really great read. He's got a lot of really interesting sources and ideas in it. So then what I did is I made it completely with off-the-shelf parts. That was part of my goal. I was able to design this all with just the Espressif and Arduino ecosystem. I'm not like an embedded systems guy, so I had to write it in a way I could understand. But I was also trying to come up with something that would be educational to other people, especially teenagers and college students who are going to be interested in this stuff and not going to be able to afford it. And so I developed an API that's just really so simple, and it lets you, do whatever you want with the microcontroller or the sensor. You can do whatever you want with the data, and you can stream it Bluetooth, Wi-Fi, USB. And there's 2 kinds of Bluetooth. And then let's see. So through this process, I actually ended up working. Well, Brain Trainer contacted me. They actually paid to develop the Peanut HEG. And for the past 4 years, they had been kind of stuck in the mud trying to create HEG. Because Peter Van Dusen, he's also very interested in create. I mean, he sells and stuff, but he's also interested in trying to like create HEGs that are more affordable. Because he's just a really strong believer in this. So he came to me because I had a really dinky working prototype about 1.5 years ago, and I was able to build one in front of him and get it working and put it on his head, and that. He decided he wanted to work with me, so I helped. So I've been helping develop prototypes with him. Now he's finally got a new piece of hardware on the way, and so basically I was able to educate myself in state-of-the-art hardware in a way to do like medical grade pulse oximetry with these devices using like affordable consumer hardware. And what's cool is what I ended up finding were these $5 ADCs that they're tailor-made to do pulse oximetry. And then they let you hook up the photodiodes in any arbitrary configuration. So there's just these really, really nice dedicated photosensors, and they're $5. And what that lets me do is design HEGs now that I could be I could be building for less than $30, like from the factory to hopefully packaging, and then could be selling them for less than $100. And then what I'm going to do, this is all open source, MIT licensed stuff, and I'm building like a cooperative business model around it, so I can get people involved that are capable and interested and passionate, And what I'm going to do is I'm going to just bottom out the market on HEG FNIRS devices that are like this, and then I'm working with hardware like so this is a single sensor HEG using a Max 30112. It's just a single channel ADC, 3,200 samples per second, 19 bits, more than you ever need for pulse oximetry. And then this one is it's kind of the Lamborghini version, and this is the prototype that I did for the Blueberry. It's a dual sensor photodiode, and then with it's a dual sensor ADC, so I can have 2 photodiode channels coming in simultaneously, both getting 4,000 samples per second at 19 bits. It's 2,000 samples per second at 19 bits, and then for 4,000 it's like 18 bits because they knock it down a peg. They promise you the best specs on the front of the data sheet, and then it gets interesting when you open it up. So what's cool is this is also the same chip I'm working with for Peter's HEG at Brain Trainer, and what that one is it's a multi-sensor array. So we're actually using this, but we've added some gating in with a GPIO timer. Well, so these ADCs have like timer GPIO pins built in, so you can actually manually sample it. And so what I can do is I can array photodiodes and LEDs, and I can then hypothetically, and we've proven this now with the state changer, that we can array these. We can very cheaply have like a multi-channel, multi-site HEG using just one of these ADCs and some simple timing math. And that's great, because these chips, again, they're like $7 to buy one of them, or they're $4 to buy 50 of them. and it's the scale, it scales amazingly well. And it gives me a lot of excitement about the idea of, providing really affordable, like really state-of-the-art FNIRS hardware. And for me, I'm I'm working on this from the perspective of just like creating a very simple sort of therapeutic device. And I want to get it to a fidelity where I can be getting actual, like, pulse oximetry data that's like medical standard stuff, and stuff that like you guys could use if you wanted in your research. And right now I'm working with this device that basically just works, and it's something that you can use to very easily educate yourself on like what HEG and some of the simpler aspects of the FNIRS science and the computer science and electrical engineering of it are like. So then I'm taking that into actual medical hardware. And what's cool is I'm able to then build my medical hardware model on top of all this open source hardware and software, and I can keep it all open sourced and, like I said, bottom out the market. And then make it so that everybody can mutually benefit from it as much as possible.
And if you could just get closer to the mic again, sorry.
Sorry.
I wanted to be clear for the recordings too, but thanks, Josh.
Yeah, I'm bad for recordings. I think this is a reoccurring issue. So moving on to my software, because it's an IoT device.
Can I ask a question before you move on? You said it can scale to multi-channel, and you probably mean indefinitely scale, or like, is there any limit in how many?
Well, the limit would just be in the timing. Well, no, I mean, really, there's no limit. It's really like how fast you want to be able to sample everything at once.
Yeah.
And it becomes, more and more of a pain in the butt on the coding and engineering side, but I mean, it's all doable.
Yeah. Cool. Thanks.
Yeah. Yeah. Anything else?
Yeah, I was just gonna say, did you? So you've you got the website, and that's not just that includes the JavaScript code too, right?
It's on my GitHub. Yeah.
It's all one GitHub. Yeah.
Yeah. Right now, things are gonna get broken up as I work on more features, but right now, just for.
Okay, terrific. And were there particular things? Sorry, I've got company. Were there particular things that? Well, I think most pressing, you were asking for anybody interested in looking at some of your hardware designs, and
oh yeah,
yeah.
So well, one of the guys who's looking at it is actually in the chat right now, Jason Vargas. But then anybody else, yeah. Okay. So I have a couple power issues right now, so I can't get these to boot. I know fundamentally the designs are sound just from the state changer work, but like this is my own work, and I'm not a professional, so I need some help. This is all BGA, like really tiny stuff, and I imagine I'm overlooking something.
Okay, you're fading out on the mic again. Sorry.
Put it in my mouth. How about that?
Okay. Yeah. Any other questions people had?
Oh, cool.
Anybody else working on NeRs at all, other than?
Well, there's a couple comments in the chat. So yeah, I can send you the slides, Nicholas. I'll put a link in the chat at the end, or when I'm done talking here. And then Andre, do I suspect production issues or firmware issues? No, so far so good. Like Now, so with the Wi-Fi, with the ESP32, there's a couple of power issues, but it's nothing that like we couldn't figure out how to filter correctly. And then now what I'm finding with the state changer hardware is that these little chips have their own isolation, so that like it goes away completely. While on my HEG Duino, it's all like completely manually done, and like all the signaling it's all manually handled, and some of the wiring things are, you know, it's basically jerry-rigged to work. Well, these new ones, they've already like these are like industry standard pulse oximetry chips, so like they're already ready to go. You can get breakout boards for like lower end versions of these, like the Max 30102 or 30105. There's free libraries to do pulse oximetry with that, and you can see all the math. It's really cool. And then firmware issues, like I've had no problems with the communications. I've been able to like these ESP32s are dual core, so I can actually do all kinds of asynchronous processes. And then they're 32 bits, and like they're powerful enough to where you can run facial recognition algorithms on them with a 720p video feed. So there's a lot of stuff we could actually end up doing with these. I don't know. I hope that answers your question. Now, so talking about the software here, I'll make this a little quick. So because it's a web, you know, it's an IoT device and it's got 4 megabytes of memory on it, I can flash software onto it, and basically I've just coded a bunch of native HTML5, JavaScript, CSS like tools, so you can open the device up like from its own IP address, or I've got a Chrome app version if you want to use it like a normal piece of software. And so you can use this thing anywhere on most devices, Apple, Android, and Windows. So far not iOS, because they're more stingy with security things. But I just need to make an app. And then like I've had a lot of practice writing web code, so I know how to write really like well-performing UIs and like all the stuff that's running real time. So it's updating at 20 samples per second. You could throttle it up to double or triple that before you start running into performance issues with the web. So that's cool. And then the way I've coded it is it's like all completely modular. It's all written in sort of templated format. Basically, I wrote an API to where you can call communications functions, and you can call different all separately as their own classes. And then it's really easy then to customize that on like a front end into your own app or UI, or if you just want to recycle some JavaScript without, you know, having to rewrite it. And then I've just showed how to do all that really, really easily. And then with that, I've demonstrated, and I can show you this after if you want to see it. I've demonstrated how well this works with my own piece of software. And I've even started working with 3JS. So now I have some cool, I have one cool 3D visual now, and I've got a bunch of I'm working on. And so like, so when you're doing feedback, oh, sorry, go ahead.
Yeah, John, so do you have a demo running?
Yeah, I mean, it's literally, let's see if I can get this. Sure. So, I got my device plugged in. Okay, cool. So, so I got my device here. I turned on my camera, but my phone seems to crash on Zoom when I'm streaming with the camera. Okay, so I've got my device on my forehead here. And here, let's show you the cool visual. So I've got this 3D globe turning, and right now it's just a default animation. When I hit start, it starts streaming data, okay? Let's see here. And so all that's happening is I'm just using the ratio, and then I'm creating a score based off of the simple moving average to the ratio to just control very simple feedback, you know, in sort of a one-dimensional way. So like right now it's measuring the ratio of red and infrared light reflecting off of my skull and hopefully my neocortex. And it's giving me this ratio back. And then I can use it to control the visuals here. And then really all I'm trying to do as an exercise, and I can lower the sensitivity to make it smoother. But,
so we can't see your JavaScript.
Yeah, I was wondering the same. Thanks, Morgan.
Okay, sorry. I've got a 4-year-old that's helping watch here.
Somehow just showed the wrong
static image. Yeah.
Oh, there you go. There you go.
Oh, that looks a lot
okay. Yeah.
Yeah, it wasn't sharing the right screen, I guess. So, so now you can see what's going on. So, yeah, it's just a very simple 3D visual of the Earth turning, and I'm making it turn with my brain blood flow. And really, these tools are just here to assist with you trying to increase that ratio. And then the inference is that we're increasing the overall, you know, blood oxygenation there, and therefore the overall, like, basically like the metabolic potential of your brain. So the amount of energy resources it has to deal with, to help with whatever processes it's doing as a biological organism. And then also that seems to also help in stress, because suddenly you have more like literal physical resilience in the form of a stronger brain in a very literal way. So yeah, very simple. It's connected through USB. I've got a bunch of different feedback methods here. These are all sort of demo methods. This one, I don't know, this one's pretty slow. It's kind of boring. This one, you just try to make it go up. Or there's a text reader here. And seems to, oh yeah, this one, it just accelerates or decelerates the text while you're trying to increase or decrease your ratio. Or the circle. What's kind of cool with this one is when you kind of get in concentration mode with the breathing, or with your breathing, you kind of start to notice that your breathing and the increase and decrease of the circle start to match, where you'll get a hump where you take a deep breath, get a rise and a fall in the radius of that circle. So you know, it's really basically like an exercise tool, and that's the point. And then you can save your data. This is all meant to be like a very simple app that's very accessible for people who just want to train and not worry about the details so much. And so yeah, I can like save my session, and it just comes up as a CSV here. Oops. Can you see this? It's not that interesting, but
yeah.
So yeah, it just comes up as a simple CSV. And let me show you here.
Josh, this is incredible. You're awesome. We're not really saying much, but this is really impressive stuff.
This is really, really cool.
Thanks. I'm really glad. Let me find my folder here.
Yeah, I plan to use this in some of my work at some point.
Sure. And then like, it's all just generic software. So like I can, you know, I want to work with everything. So, you know, get in touch. Let's see, data charter, here we go. So I just made a really simple little tool. On my website, I threw it in as an iframe. So here you can see, I was just holding this sensor on my head. So it's pretty noisy, but you can still garner a ratio here, and you can still roughly see that there's a trend, okay? And so that would tell me that I'm roughly improving my brain blood perfusion through this duration here. Now, I can actually, when I'm in ideal conditions here with my sensor, I can actually see my pulse clear as day. So I know my hardware is working pretty decently for the most part. And then even under not very ideal conditions like this, when I'm just, you know, it's still good enough to do the training, and that's the point. So I'm happy with it.
So Josh, I think this is fantastic. I think that one of the biggest limitations in getting this to work at a big scale is the interface between the lens of the optics and the skin.
Right.
And I know that John has been coming up with some different solutions, and the glasses are a good one. So if you've been thinking so much about this, what have you thought in that regard?
Well, so, you know, the simplest solution I found is throw a screen protector over it, and that stops the sweat. And you can just tape it down, and or you know, you can do something nicer if you want to do production level thing. Now what they do at now what they actually do in with industrial design, from what I've learned with the State Changer project, is that they do like a silicone gel and or some kind of epoxy that they can put down really, really thin, so it's completely coated and waterproof, and it's durable too. So it's not going to, you know, rub off with use, at least for a while.
Yeah, I guess I don't even mean the material interface, but the mechanics of the interface, such that the optics don't change over time. That seems to be having tested the Blueberries prototypes, like, and having tried a whole bunch of different systems, the biggest source of noise is always the detachment of the optic fiber or the LED lens from the skin itself.
Sure. Now, yeah, you know,
Sorry, Kyle, are you talking about like, so the headband and just maintaining its contact with the skin?
Yeah.
Yeah.
Right. So
okay.
For me,
which is kind of the same problem with fiber too, right?
Yeah.
Right.
Yeah.
So for me, you know, I'm working with these flat sensors, and I'm working with flexible PCBs. And then and I'm just throwing in a headband. So like roughly, like, it conforms really well for one.
Yeah.
So I know I'm always getting pretty decent skin contact, you know, and you can feel it really easily. And then with a good enough headband, you can secure it on really well. Now, you know, in testing circumstances, I suppose you still probably can't move much. I mean, especially if you're trying to get like an actual image.
But we want to move, Josh. That's what I'm saying. We want to move.
I know. Well, I think with these flat sensors, this is the best bet for being able to do that. Just my 2 cents here.
Yeah, I think the heart, like the cinching with the headband, is important, and pushing it into the skin. But yeah, I'm just thinking that optic fibers are good. We tried making really thin electronics that adhere to the skin, but I think the mechanical from elastic force is like the best option.
This is an idea that Josh and I were talking about before. Maybe it doesn't fully solve the solution, but we're thinking about like a clip-on or a mountable Epner sensor that can just like click into the open BCI hardware, just the cap, you know.
That's
so
great.
If it clicks onto that, then I mean, you'll still have some contact issues, but that's a lot more secure, I guess.
Not shoving it up the nose.
And I would, yeah, I'm sorry.
You don't want to try to shove it up someone's nose?
Yeah, not yet.
I had mentioned that, and so I was talking about the intranasal, and of course I don't know if anybody saw the post of the mouth OPM. I posted on Slack, which that was a new one to me, but yeah, there are other places. Could you say, I mean, Kyle, what would your guess be in terms of, I mean, is there a sampling rate issue, or is there some sort of quality issue that would that prevents people from estimating more of the direct, you know, physiological parameters with units?
Oh, I think that Josh knows too. You mean in terms of the ratio of hemoglobin?
Yeah, I mean, in terms of.
So the problem is that you need to know the absorption at each of the 2 wavelengths of the skin, and that's a hard thing to estimate. And because those are 2 parameters of the Beer-Lambert law equation. So you don't just need to know the light that came back from each light source, but you also want to know the absorption, if I understand correctly, Josh. And so that's a hard thing to estimate without using phantoms and without, you know, measuring it for each user.
Well, I mean, certainly, you know, one of the first things that we want to do for EIT is make a phantom. Are there kind of like, are there simple phantom systems that are easy to set up for testing NIRS? What
the companies send is like a cloudy, waxy kind of substance, but milk is the easiest thing to use.
Okay, interesting.
It has the same scattering properties as, but I don't, yeah, it matters what you're trying to test, because if you want to be able to measure the pulsatile signal, then you want a phantom that can pulse.
Yeah, definitely. And Josh, there's no sampling rate issue, or what's the spec difference on the next gen photodiode or pulse ox?
What you can get for more money is more sensitive detectors and brighter sources, and so you get better signal to noise.
So okay, that's great, and
probably faster ADC, like Andre's suggesting in the chat. So you can, if you spend more than $5, you can sample more channels fast.
Yeah. Well, I'd love to see what we can do with one in terms of actually getting some of those measures. And compare it with, I mean, I don't know anybody at UCSF that's doing NIRS, but there's definitely some people down Stanford. I mean, I would love to, you know, put this in between a bunch of another system and see what they're both seeing.
Yeah, and then there's another issue about optical imaging. Well, you know that you can measure a fast signal as well, but that you need to use different tech as well, because you need to measure the average time that the light's taking to go through the tissue.
And does that, so what's, so thank you, Josh.
Yeah.
If there's nothing else, we're gonna kind of move on to some extra issues, and I certainly got questions for Kyle. I'd love to save arrows for, you know,
Yeah,
next
let's
week.
do that. I can put some slides together and show you guys some things, but in terms of portable technology, it's not going to be like NIRS is going to be the way to go. It's such a stronger signal to noise.
Yeah. Okay. Well, if we could use this week in terms of you know, good papers that get at any of the kind of hardware issues that that Josh is going to be seeing, if he sorry, Josh, did you want to finish those slides?
Josh, we can't hear you. Oh, that's a picture from my old lab.
You're muted, Josh. If you're trying to speak, you're muted.
Josh.
Oh, weird. It put me in safe driving mode.
Oh, there you go.
Okay. All right. Hopefully that doesn't cut me off. Okay. Well, so real briefly, so the way I accomplished this is I live in a cabin, and it was like one of the coldest winters in like 30 years. So I pretty much, it was me and a couple buddies in my cabin. We built, I sold about 200 of these HEGs through crowd supply. And so I was able to afford to, order a couple hundred of these things and build them and send them out to people. Now this week I've sold another like 225 products, which is really exciting for me. And that's to CrowdSupply and OpenBCI, both really awesome groups. And I've got about 100 in the actual hands of people right now, and so far so good. All the technical issues we've covered them and we've gotten through, and people are able to use it. And then the results of the people that are reporting to me so far about how they feel after doing their brain exercises, they're very typical patterns of what we think we're supposed to see when people are doing brain exercise. They're feeling like a certain kind of fatigue in their brains after doing the exercises, and then over time the fatigue, it's like, it seems to be working, and that's really great, because I've I've done the most like I don't know, it's like a super versatile, but it's again, it's completely off the shelf like HEG brain training device, and I've done it in a way where it's like, I mean, anybody could take it and reproduce it tomorrow if they wanted, and do something probably 10 times higher fidelity. But then I provided all these tools, and it's great because now I get to work with all you guys potentially, and keep moving forward. And then right now, I think I'm one of the only people selling, or the only person selling an FNIRS device for less than $100. That's not like a pulse oximeter. That's cool. Yeah, I do this because I love it, and it's been a total trip. And then moving into the future, like I had talked with you guys about, I want to work on multi-channel HEGs. I want to improve just the single HEG model, obviously. I want to get this stuff, working with other types of, imaging methods like EEG. That's the natural progression here. I want to learn how to do tomography. I've heard that, if you flash these lights fast enough, you can start doing potentially 3D structural imaging. You guys, you can correct me on that. But that's, those are cool ideas, because then they become stepping stones into like all kinds of tissue imaging using, safe spectrums of light and sort of like imaging methods that we could potentially produce out of like FNIRS and other similar types of research fields. And then I want to do this openly. I guess I'm a dirty hippie. I want this to be available for everybody that needs it, and I want to help find the advances in medical brain science that we need, so that people can heal and live better lives, and that we can have awesomer social circumstances. The whole thing. I want a better world, and I think projects like these are going to get us there, or they're going to help get us there. It's all, we're all in this together, right? And then what's cool is building on the IoT and the open source is like we've already got this whole ecosystem and all this language for doing this, and we just have to take advantage of it. And then also just in the past few years, we've also gotten the hardware that's cheap enough and capable enough to put my money where my mouth is, right? And then so going forward, bottlenecks. Right now, I'm a one-man army. I've got a couple people helping me here and there, and hopefully they'll become more integrated in this project if they want. And then I have a number of challenges I want to meet. Engineering wise, it's like coming up with the best hardware, right? And that meets all my goals of multi-site, multi-modality, and dirt cheap, under $100 or $200 if we're even doing combined measurements. Because it's just so possible right now. It's just a matter of like sucking it up and charging less. I'm sorry to say, and then using the stuff that's going to be, make it feasible. Because it is, some hardware, right? It goes from $5 up to $500,000 pretty quickly when you're looking. And then clinically, I would like to very much prove that the brain exercise idea is real and legitimate, and And I want to see, all the studies I've read about FNIRS and brain and doing the blood flow brain training is that it's like 70% of the people that do it with any kind of sort of developmental or affective disorder, it seems to help them in some way, and it seems to help them deal with the stress and some of the long-term effects of their illnesses. And that's something that is like, that's really profound because it's not medical. It's like not a pharmaceutical solution. It's not something that takes 10 years to figure out. And then it's perfectly complementary with everything else that these people should be doing to take care of themselves. So that's cool. To me, it's like a natural fit as another tool that we can and should be using, given the data supports it. Right? I gotta be scientific about it too, as much as it is exciting. And then I need a team to do this too. Like I said, I'm working alone here. I got a lot of ideas that I want to work with other people on and work with their ideas. And there's so much to this. I'm an outsider. I live in a cabin in Alaska, and I made a lot of my money foraging mushrooms and picking chaga and like hustling like that. And I would like to build a community. Alaska's got a lot of problems in terms of the education and mental health. It's a disaster. And so for like a project like mine could be really powerful just for enriching like Alaskan education and health, things like that. And I'm already working on projects like that.
Hey, Josh. That's Josh talking, right?
Yeah. Can you hear me?
I managed to get one of the Blueberry FNIRS devices, and I'm really interested. I've been spending time working on developing a 3D WebXR application for biofeedback with FNIRS, and like I've been coding all day long here on my application. Okay. In the past, we got WebXR to work with EEG, so I'm very confident that we can even use the project that we accomplished in 2018 and adapt that. But what I'm really interested in from you, and I'd like to help you, is to know more. Like you were saying that if you speed up the sampling rate of the FNIRS, you can start to create 3D modeling. What's the basis of that?
I don't know that for sure. So, I know with multiple sensors, you can start doing computed tomography and doing like 2D. You can start doing like rough 2D maps. Now, this just came up really in conversation with like Michael and some other people. One of the things I've been looking into is like, I would love to figure out how to do like actual 3D imaging. Right now you can do it like with a CT scan, but you got to blast yourself with a ton of radiation, or you can sit in an MRI machine for an hour or how many hours to do like a full scan. And those are obviously extremely useful, but it's interesting to me the idea of how do we do this with just light, and optics. Now, in my mind, what I think is you probably have to be able to like, it's like those laser distance sensors or whatever. You have to be able to actually see what's going on with the wavelengths at like the speed of light, or at least within the frequency range, the Nyquist range, right? For sampling that frequency. And but then I heard that supposedly if you're flashing the lights fast enough, basically the absorption and re-emission time of the matter itself in your brain starts to create like oscillations. Again, you guys can correct me on this. This is just stuff I've read and heard and cooked up in my own brain.
So I mean, the fastest way to do this is to find those references and pass those along.
Yeah, sure, I'll look for those.
And certainly we know with multi-channel systems, by having a model that also has, either MR for the subject or is using a standardized brain, we know how to incorporate that spatial information and produce maps of the absorption changes, sort of like you saw with the pictures with the soterics, and there's and then in terms of things that you can do with light, it's the people who are doing microscopy are doing the most advanced kind of 3D.
I could clarify. I think there's like two different concepts that are being conflated. One is the NIRS right now, what we're seeing is measuring blood flow, which happens about 6 seconds after neurons fire. When neurons fire, however, they change in their scattering properties, so they swell up with extracellular fluid, and they bounce the light a little bit differently. And that's called the fast optical signal compared to like the slow optical signal, which is caused by light being absorbed by the color molecules in the hemoglobin and differentially absorbed by oxygenated and deoxygenated hemoglobin, because they have different number of oxygens bound to them. And so in order to measure depth, you don't need to measure that scattering change. You just need to measure from different source detector distances, because the light is most likely to travel through like a banana-shaped path through the tissue, which we've seen some pictures of. And the further apart the source and detector are, the deeper that tissue will be that the light travels through. So by combining a bunch of channels of different source detector distances in an overlapping part of the head, you can recreate depth, which is also what they do for tumor reconstruction.
Okay, sure.
Yeah.
I've heard that. And then with FNIRS, you can get like a 5 centimeter penetration.
And then I think you were even getting at the easy way to measure scattering changes, because you do have to estimate the time of the speed of light, is you can like put in one photon and wait and see how long it takes for it to come back, and it'll be like a couple picoseconds or something.
Right, I've used those distance things.
Yeah, Josh, could you unshare your screen for a second?
Oh yeah, sure.
And yeah, we were so I'm hoping that we'll get Dr. Fang to join us at some point too, Kyle. I mean, this certainly is his ISO. A lot of people know him from his ISO to mesh code, but these are some of the things, some of the projects that he also develops, and he's very responsive and maintains these for us in NeuroFedora too.
Can I just request, Josh, would you consider sharing your slides, or at least the references, a list of those references, so I can go through them later?
Yeah, sure. I will. Here's the slides again in the chat. Oops, sorry, that was a private chat. Hold on. Here we go. Here's. So I have a whole bunch of other references. Those are just a very small handful. But one of those references in there has like 5 pages of links on NIRS and cerebral blood flow testing, and I mean, amazing stuff. So yeah.
Awesome. And yeah, so thanks again, Josh. That was terrific. And I really, hopefully we can use Slack and, and your GitHub to stay in touch, and hopefully some people will have some feedback for you in terms of the hardware. Certainly I'd love to, if there's things to do, separate, kind of like controller code from your JavaScript visualization. That might be another place that someone's interested in helping. And Yeah, and
Separate,
actually,
sort of.
sorry.
I mean, they are separate. They're just
okay.
They're differently organized. Like there's the hard
Gotcha.
work that there's a bunch of text saved as HTML basically.
Gotcha. Well, so check out OpenNeur's channel on Slack, and we will be following up on this particular theme with and you know, not to press Kyle, it's been great to have you, especially for years, to talk about Eros next time, or when you have time, Kyle, and to talk about scattering. And I'm going to ask Dr. Feng to join us to talk about you know, computational, especially the kind of spatial integration that we were talking about, or you know, NIRS mapping and other biomedical optics.
Yeah, we just got our $300,000 optical imaging system, and it's sitting in a locked building for the next couple of months. So it's really exciting.
It's could you organize a heist?
There might be a heist, but yeah.
Okay, because I'm kind of glad that I've still got some equipment downstairs in my house.
I do have equipment, but I didn't take that one.
Okay. Well, yeah. So if anybody's interested in working on OpenVibe access to electrical geodesics AMP, I will offer remote access. So terrific. So we're kind of wrapping up. It's the last 10 minutes. Anybody have any burning questions? Anything that they'd like to see for next week? Anything, you know, you don't have to answer right now, but please get in touch. And yeah, give it one last chance for any introductions of anybody who's joined us since the last time we did introductions.
I joined since the last time we did introductions.
Hi, Abby. Yeah.
Okay,
Yeah,
hi guys.
Would you, what are you interested in? And if you have a background in neurotech, can you tell us about it?
Yeah, definitely. So my name is Abby. I'm currently in the process of graduating from my biomedical engineering degree at Queen's in Ontario, Canada. I started the student chapter out of Queen's along with this guy named Omri Nachmani, who some of you guys may have known from previous calls. And I also worked at Interaxon this past summer on the research team working on the Muse. But so the main reason I kind of stuck my neck out and introduced myself was right now I'm writing a thesis, and it's the only thing left in my degree. So I'm spending the next month and a half solely based on that, and it's actually around FNIRS. And I'm trying to connect PPG relative blood velocity levels to FNIR data to try and qualitatively connect how hypertension and normal contexts of blood flow in bodies can affect FNIR data. So I've done a ton of theoretical research and developed a theoretical model, but have been cut short in terms of collecting empirical data on this. So if anyone's interested in talking about this with me at all, or wants to just kind of discuss this connection in general, I'd love to talk about it with people, because I think my housemates are bored of me.
Totally understand. And yeah, we're all dealing with problems like that, but yeah, it's got to be tough also doing your thesis. What can you say something about are you doing any simulation work?
Yes, so I've developed a MATLAB model based off of a arterial simulated network. So it's focusing specifically on the basilar artery and trying to connect that to the differences in cognitive functionality. And so I have a currently developed MATLAB model, but I'm trying to empirically mimic it right now.
Sure. Okay. So you've gotten everything you want out of simulations.
Well, now that I can't test, I may as well just continue on with them. But
yeah, I was gonna say like I mean, I don't know how many NIRS, experimental systems we're gonna find that's internet ready, but certainly please join the Open NIRS chat. I mean, in terms of, that's certainly where I'd love to see more papers that they're relevant for NIRS, and like, certainly having Josh present was sorry, that is my daughter. Having Josh present this was a way for us to really open the discussion, so we weren't so EEG focused. So awesome that you're also working on NIRS. And yeah, I mean, I don't, so you're not interested necessarily in how hypertensive brains are changing structurally.
Oh, I definitely am interested in that.
Okay.
There's few things in neurotech I'm not interested in.
Okay, gotcha. I mean, just I don't know if this would be useful, but obviously, one of the amazing, UK Biobank is this like incredible data sets, right? And I'm pretty sure it's got some really remarkable, one, it's got older subjects, and two, it's got, I believe it's got MRAs in everybody. And I mean, ideally with like hypertensive, you'd want some other kind of structural scans that would get it. Anyway, this would be something that maybe Dr. Fang, who does NIRS with people and also has MRIs, might have something to say about. But thank you for sticking your neck out. And yeah, anybody else? Kelly. Yeah, hi.
Hey, how's it going, everyone? Thanks for talking. I'm friends with Josh, and he opened me up to the.
Okay.
oh yeah, I'm Kelly, and I'm working with Josh on getting it into music education, that music program I teach here in Fairbanks, Alaska, and looking at integrating HEG, like help build the infrastructure in the brain, and then looking at using EEGs to help facilitate like mindfulness or promote musical acuity in their performance. And we're looking at working with the program I teach, but also the university. So it's not just younger kids, it's also adults.
Sure. So I know in a recent introduction on Slack, I don't know if you've joined the Slack channel.
Not yet.
Neurotech. Okay. You can hit us up for details to get to join. But yeah, somebody just recently joined, interested in at least the neural signals associated with music. I would love to see, and it seemed like Xavier last week, the student who's at a kind of tech art school, if I remember correctly, was also kind of sonifying, biosignals. So turning the signals into sound, which is something you could do with Josh's system too. Yeah. Well, thanks for speaking up or introducing yourself.
Thank you.
Anybody else? I know we've just got technically a couple more minutes. Let me just check the agenda and see. So I think we covered everything. I wanted to bring up that I was able to use EEG Lab with Octave, which I thought was pretty cool. And so I didn't require a MATLAB license, and that was nice functionality. You still get a lot of warnings. in the EEG Lab quarterly newsletter, I mentioned this to John, especially with everybody home, or everybody locked out of their institutions. The ideas are, being able to develop these kind of at-home systems would be pretty powerful. It'll be powerful when this is over too. But because we were always interested in trying to get patients to take systems home with them. So yeah, I'm putting on our action items for next week to hopefully somebody, if you have a Mac, if you could download the EEG notebooks and follow the instructions and see what breaks. Nick's gonna try and do the same for Windows 10 and anybody else, and Alex M might help him. And we're gonna follow up with Kyle next week, or Kyle when he's ready, but certainly we'll have a chance. I'm gonna try and send out at least a couple references people look at before people are talking that might be useful to get some background and context.
I just posted in the Slack a folder of about 200 papers. If that's too many.
Would you want to pick maybe two? So I mean, I was kind of curious. Okay. So.